Welcome back, guys. We are going to do another numerical on lasers. Okay, so the question is, there is a ruby laser which emits 10 joule of energy with wavelength of 600 nanometers. Okay, so let's write down what we are looking at. It's a ruby laser with energy output of 10 joules of energy. Okay, and second information given is lambda is 600 nanometers. It means 600 into 10 raised to power minus 9 meters. So lambda is 6 into 10 raised to power minus 7 meters. Okay. Now it's saying that if chromium ions are responsible in laser action, what is their numbers? Okay, so we have to find out number of chromium ions. So in questions that would be asked in laser, you have to remember one thing, that whenever this is metastable state, this is your ground state, okay, and let me change color. And whenever we say that one atom changes its state from metastable to ground, an electron will jump from metastable state to ground state. So this electron will jump here, right? And what happens? One photon will be released. Okay, one electron jump will give rise to one photon emission, and it means that if one atom is taking part in the laser action, then one photon will be emitted. So this is the point that you have to remember. So actually the question will become to find out the number of atoms, chromium ions. Actually the question will become to find out the number of photons emitted. Okay, so we will take it at in 1 second. Okay, so consider that 10 joule of energy in 1 second. So we will be finding out how many chromium ions per second are taking part in the laser action. Okay, so our question has now become to find out the number of photons. So number of photons, how we are going to find them? So we can find it from total laser energy divided by energy of one photon. Okay, so let's find it out. So number of photon will be, total laser energy is 10 joule in 1 second. So we are considering in 1 second. If you are considering, so you can write just 10 joules upon energy of one photon. So we have to write energy of one photon. Okay, so let's find out energy of one photon. Okay, so energy of photon can be given by h nu or hc by lambda, where h equals to 6.6 into 10 to the power minus 34 joule second. C is 3 into 10 raised to power 8 meters per second, and lambda is given as 6 into 10 to the power minus 7 meters. This is here. Okay, so let me change color again so that it will visible in blue also. So okay, let's find out. So we know, okay, let's find out E photon. So it would be 6.6 into 10 to the power minus 34, that is H, into C 3 into 10 raised to the power 8 by lambda, that is 6 into 10 raised to the power minus 7 meters. Okay, so that was switch to black, and so E of one photon is, okay, here it is 6, so this would be 1.1, and 3 into 1.1, that would be 3.3 into 10 raised to power how much, minus 34 plus 8 plus 7, so minus 34 plus 15, so minus 34 plus 15. Okay, so energy of one photon is about 3.3 into 10 raised to power minus 19 joules. Okay, so let's apply this formula now. So number of photons taking part in 1 second or emitting out in 1 second would be 10 upon 3.3 into 10 raised to power minus 19 joules, and there also it is joule. Joule and joule will cancel out and we will get a number. So number of photon are, okay, so this would be 10 to power 18, and 10 by 3.3 is almost 3 into 10 raised to power plus 19. Okay, so this is the number of photons. So our answer is number of chromium atom or chromium ions will be equals to 3 into 10 raised to power 19 in 1 second. Okay, so this is the answer, and that's how you are going to do the numerical on laser. Thank you.